Hello, Year 11. So today we are looking at our exponential equations. Now there's 5 different types that I've summarized it into. So we're going to start with the first type, where we're solving exponentials that have the same base. So these are definitely the easiest ones, where it's pretty obvious straight away how we can go about solving it. If 3 to the power of x plus 1 is equal to 3 to the power of 5, well then we know that, x plus 1 must equal 5. And then we just solve that equation and we get x equals 4. And then you can substitute it in. If I substitute it in where x is, I get 3 to the power of 4 plus 1. Does that equal 3 to the power of 5? Yes, it does. So these ones are nice and straightforward. So the next one, we know that any number on its own has a power of 1. So then we can say, therefore, 1 is equal to 2x minus 3. So then we have 4 equals 2x, so therefore x equals 2. Okay, so now we look at ones where they're different bases. So here's our 3 questions, copy those down. They're always going to be, for now, in this category, nice numbers where we can rewrite it with the same base. So, for instance, 125, I know that's 5 to the power of 3. So now I'm just manipulating it so they do have the same bases. So therefore, x is going to be 3. So it's knowing your squares and cubes pretty well for these. So this next one, 4, that's 2 to the power of 2. And then that is to the power of x is equal to 2 to the power of x minus 3. Using our index laws, when we have brackets, we would times. So I could go one more line and say, that's just 2 to the power of 2x equals 2 to the power of x minus 3, which gives me just 2x equals x minus 3. So if I bring the x over, I get 2x minus an x equals negative 3. So x equals negative 3. Okay, so if you want to pause the video, give this last one a go on your own. Otherwise, let's have a look. I can see here 3 is my common base. So I'd say, 9 is 3 squared. Now don't skip too many steps here. 3 cubed is 27. Now simplifying out. Be careful there. It's going to be 2 timesing by x plus 2, which will become 2x plus 4. And that's equal to 3 to the power of 3x. Now we can see, 2x plus 4 must equal 3x. Bring the 2x over, I get 4 is equal to 3x minus 2x, which is x. So those ones are easily manipulatable, if that's a word, to then have the same base. Alright, now let's look at some harder ones. What about when we have fractions involved? This is about remembering our negative indices. So, I can see, what's my common base number? It looks like it's going to be 2. A half is really 2 to the power of negative 1, because using our index laws, 2 to the power of positive 1, we bring it up, it becomes a negative. And that's to the power of x, and 4 is 2 squared. So simplifying it, I get 2 to the power of negative x is equal to 2 to the power of 2. So therefore, negative x must equal 2. So x equals negative 2. Okay, pause and give B a go if you like. Alright, so 4 is my base here, because I know, in the back of my head, I'm thinking straight away, 4 times 4 is 16, times 4 gives me 64. So 4 cubed is 64. So if I break it up into a few steps here, I say, I know that's just 4 cubed. But then if I make it no fraction, that's 4 to the power of negative 3. So therefore, x plus 1 equals negative 3. So x equals negative 4. Okay. Alright, my favourite ones. Reducible exponentials. Now I've just made these numbers up on my own, so hopefully they all work out okay. So, they're reducible because back in the day, we learnt, actually at the start of the year, some reducible quadratic equations. Let me just give you a quick flashback. It would be something like this. X to the power of 4 plus x squared, trying to think of numbers that'll work, minus 6 equals 0. If I had to solve this, we would call this a reducible quadratic, because we would say, what about if I just let u equal x to the power of 4? And if I do that, x to the power of 2. Then I'm going to have, okay, well that's going to be u squared, because it's power of 4, plus u minus 6. And then I say, oh, okay, this becomes a quadratic that I could solve. What times is to give me negative 6, and pluses or minus to give me a 1. I'd have 3 and 2, and positive 3 minus 2, so therefore u equals negative 3 and positive 2. So we called those reducible quadratics. We're going to do a very similar thing now with our exponentials. And I'm going to change one thing straight away. Could you please make that a minus, just to make the question a little bit nicer? They're still going to be ugly, but make that a minus there. Okay, so what I'm going to do here is I'm going to let u equal 2 to the power of x, and you're going to see in a moment why that is. If I do that, well, this is going to be, I know that 4 to the power of x is 2 squared, all to the power of x becomes 2 to the power of 2x. So what I end up with, if that is the same thing, so I won't jump steps, 2 squared to the power of x is what 4 to the power of x is. And then using my laws of indices, brackets I times, so that would become 2 to the power of 2x, which then I could manipulate as 2 to the power of x squared, because see how that's going to give me the same answer anyway? So if I do that, I say, well, that's the same thing as 2 to the power of x squared minus 7, and this isn't a decimal, it's a times, timesing by 2 to the power of x plus 12. Now you can see why I'm going to let u equal 2 to the power of x. If I do that, I'm going to get u squared minus 7u plus 12 equals 0. Now when I solve this quadratic, I get u and u, minus 3 minus 4 equals 0. So therefore u equals positive 3 and positive 4. But remember, which I didn't show you in that last flashback question, we don't want what u is, we want what x is. We come back to what we made our substitution. U was equal to 2x. So therefore, now what we have is that 2 to the power of x is equal to 3, and 2 to the power of x is equal to 4. Which still hasn't got us an answer, because we need to find x equals and x equals. If I was in person with you right now, I would say, what should I do? How would I get x? Now hopefully you can see, well, this one's just going to be 2, because I know x, 2 to the power of 2 is 4, so that's a nice one. But the question is, how do I solve this one? 2 to the power of x equals 3. Well, you might be thinking, I know, miss, we did this last lesson. We could log both sides or do a change of base, whichever one you preferred. If I log both sides, I'm going to get x timesing by log of 2 equals log of 3. So therefore x is equal to log of 3 on log of 2. And you can put that in your calculator and you'll get some decimal. But there are your two answers for x. Alright, so it's a lot to take in, but I like them. They're challenging. I want you now to give B a go. So pause the video if you like, give it a go. Otherwise, I'll assume you've done it now. So we've got 9 to the power of x. So the first thing I can see is my base looks like a 3. So I say, well, that's the same thing as 3 to the power of 2x. And you can skip this line and jump straight to knowing that that's the same thing then as this. But I'd definitely at least show this line, this second line here. Okay, so now, and tell them what you're going to let u equal. Let u equal, and they always seem to use u, but you could use any letter. u squared plus u minus 2 equals 0. Factorise. Now, one thing to note, if you couldn't factorise, most of the ones I've ever seen, they give you can factorise. But for some reason, if your quadratic won't factorise, what are you going to do? Quadratic formula. So they could definitely be really nasty and make you do quadratic formula, but I'm not going to do that. What do we get? Positive 2 and negative 1, which then we get u equals positive 1 and negative 2. Now this one's interesting. Now if we come up, we know we let u equal 3 to the power of x, so therefore 3 to the power of x is going to equal 1, and 3 to the power of x is going to equal negative 2. Alright, this one. Interesting. You might have, if you already had a go at this, log both sides, but without even doing that, I know anything to the power of 0 will give me 1. So that tells me that x must be 0 in this one, because anything to the power of 0 gives me 1. And this one actually has no solution. The reason is, think about the graph. 3 to the power of x, I know that that looks something like this, because it's positive and it goes that way. There is no solution for any negative values. So that's why whenever you have an exponent and it's equal to a negative number, there's no solution. So the only answer to that question is 0. Alright, how are we going? One more, which these ones you actually already know. So exponentials are now equations when they're not nice numbers, and that's where we can do our log both sides, or we can do our change of base, whichever way you prefer. I think I mentioned in the last video, I definitely like to do log both sides. It just comes up more often. And I'm just going to show you each step here, but you can definitely skip some of these steps. And you should get, I just did 2dp. Alright, pause the video if you want to give the second one a go, but otherwise if I log both sides again, so once you get to here, I would just leave it in the exact form rather than trying to get a decimal so we don't affect our answer. So after this, I'm going to take the negative 1 over and plus it. And then the last thing I'll do is actually square root. So notice though, if I'm square rooting, I'm going to get two answers, plus minus. And make sure in your calculator that plus 1 is under the square root, so you should get plus or minus. If I just do the 2dp, 2.3, that'll round up to 4. Okay, so there's my summary of 5 different types of exponential equations. So today's exercise, I'd like you to have a go at exercise 807, and I just want questions 1 to 4. Okay, we're going to come back to the rest of the exercise in another lesson. So just questions 1 to 4, but I'm going to be mean and make you do all letters, please.